Okay, 7.3, the law of cosines. We have to be equal opportunity here. If there's a law of sines, there's got to be a law of cosines. There are really three forms. A squared equals b squared plus c squared minus 2bc cosine of A, angle A. We're going to use alpha, I guess, for that also. You switch the letters around. B squared equals a squared plus c squared minus 2ac cosine big B, known as the A on the left, the big A, little b, big B, and c squared equals a squared plus b squared minus 2ab cosine angle C. These A's, B's, and C's are going to be the vertices of our triangle. So I'm going to use alpha, beta, and gamma for the labeling the triangles. Let's take a look at this big triangle. This is our A, B, and C. And of course, the sides opposite are little a, little b, and little c. We're going to drop a perpendicular here and put in a right angle. So this is our alpha. I guess I wanted this to be B and this to be C. Doesn't really matter, just keep my letters straight here. This is H. This is the angle gamma up here, and this is beta over here. Okay, now we need these parts. This part here is going to be E, and this part here is going to be D, just so we got everything labeled. Okay, remember this is now C and this is now B. So, first of all, we're going to prove this first one, and all you have to do then is just really change the letters to get the other two. It doesn't matter which angle or side you choose, you can set it up any of those three ways. We're just choosing the first one to prove. So the first thing we're going to do, what is the cosine of alpha? Well, if we use this right triangle, cosine of alpha is h over d, right? I'm sorry, that's sine. It's d over b, right? Okay. Keep that in mind. We'll call that I. We also need that, what is d plus e? Well, that's the same as c, but we really don't want d plus e. We want e all by itself, so that's c minus d. We're going to call this II. Now we need b squared equals d squared plus h squared. B squared is a hypotenuse, d squared and h squared are the two legs. But we're going to rewrite that as h squared equals, so that's going to be b squared minus d squared. Subtract that. This is going to be a third thing we need. And next we're going to take a squared equals e squared plus h squared. A squared is e squared plus h squared, that right triangle on the right. We're going to plug in II for the e. So a squared is going to be equal to not e squared, but c minus d squared plus h squared. And then we're going to take the III and replace the h squared with the b squared minus d squared. So a squared equals c minus d squared, and instead of h squared, it's going to be b squared minus d squared. Okay, and oh, I'm sorry. Then we're going to put into the d squareds, where is it? Here, I guess we really want to rewrite this one as d is equal to b cosine alpha. If we multiply both sides by b, d is equal to b cosine alpha. So we get a squared is equal to c minus d, which is b cosine alpha. And that c minus d is squared, plus b squared minus, remember d is b cosine alpha squared. Now, what was all that about? I don't want E, I don't want D. I want A, B, and C, and A, the angle A, which I'm going to call alpha. Okay? And if I start working this all out, if we square everything. Now, when you square a binomial, you square the first minus double the product. So that's BC cosine alpha plus square the second, which is b squared cosine squared alpha, plus b squared minus, and this just because it's a multiplication, b squared cosine squared alpha. Okay, if you look at all this stuff, there's a b squared cosine squared alpha, there's a negative b squared cosine squared alpha. Get rid of those two, and let's collect this and reorder them. Put the b squared first, then the c squared, then the minus 2bc cosine alpha, and we have our form. So that's one way of showing you how to get the law of cosines. Now you might say to yourself, well, hold on, what about that situation where, you know, this is sort of nice. What if your right triangles aren't as nice and you've got something that's outside? Well, we can do that quickly on a different sheet of paper. Suppose your picture is now like this. Let me get my letters here. Call this B. We just flip this over, I guess. C, and this is A. So this is the gamma. This is beta. This is alpha. But now, to get a right triangle, you're going to have to extend this base, because this is C and this is B, and this is A here, to get a right triangle. We're going to call this length D, just goes up to here. B is this side of the triangle. And of course, this is H, the height of that triangle. So, can we still get this? Well, first of all, let's look at this angle right here. Well, remember, this is the gamma. That angle is 180 minus gamma. So what is the cosine of 180 degrees minus gamma? Well, that is the cosine is the adjacent, D, over A, the hypotenuse. So A times the cosine of 180 degrees minus gamma is equal to D. If we take a look at this difference, A times the cosine of the first, 180 degrees, cosine of the second, gamma, plus, instead of minus, the sine of the first, 180 degrees, the sine of the second, gamma, and that equals D. What is the cosine of 180 degrees? 180 is over here. This is the point 0, -1. Cosine is -1. The sine is 0. So this disappears, and this is really just -a cosine gamma equals d. Keep that in mind. You also have a squared equals h squared plus d squared. A squared, this is h squared plus d squared. And we want to just solve that for h squared. So it's the a squared minus d squared. Keep that around. Okay. So in this big right triangle, the Pythagorean theorem gives us h squared. And this is b plus d, quantity squared. And that equals the hypotenuse c squared. So h squared is going to become a squared plus minus d squared. D plus b, quantity squared. I'm sorry. D is, we're going to let that be d. So d squared, well, that's in a second. Let me do this and just put b plus d squared. And that equals c squared. Okay, for the d, we're going to use this right here. So it's a squared minus -a cosine gamma squared plus, this is b plus not d, but a -a cosine gamma squared equals c squared. So when we square this, that negative gets squared, and it'll be minus a squared cosine squared gamma. This becomes b squared, square the first, double the product, minus 2ab cosine gamma, and then square the second, which is a positive a squared cosine squared gamma. And that equals c squared. So this negative a squared cosine squared gamma, positive a squared cosine squared gamma, gives us a squared plus b squared minus 2ab cosine gamma, and that's what c squared is. So you still get that pattern. It doesn't matter. You can flip things over. That 180 is really just a 0 and a -1 in there, which doesn't change anything. So now that we know the trig functions and the law of that takes care of right triangles. The law of sines and the law of cosines takes care of all the rest of the triangles. We can solve any triangle we'd like. Also remember, well, let's go through this again. Law of sines is what I would try to start with and see if it works. A over sine A, B over sine B, C over sine C, that's the same ratio. The law of cosines, I really think of it as just one of these, whichever one you prefer. Some people like this third one because it sounds like a squared plus b squared equals c squared. But you've got to adjust that because it's not a right triangle. It's minus 2ab. The 2 on that side. Cosine c is the same as on the other side. We can also find areas of triangles, and we have several formulas for that. One of them we're not going to prove. We've already proved the other, but it's worth remembering these things. Of course, the area of any triangle is 1/2 the base times the height, This is the base, and this is perpendicular distance, the height. But if you don't have that, it's 1/2 AB cosine, or sine C. Remember, you have to use all three letters. So it doesn't matter which angle you use. Here's ABC, little a is across, little b is across, little c. So if we use angle C, we need sides A and B. If we use A, we need sides B and C. We need all three letters. But there's also one that uses just the sides that it would take a little time to prove. In fact, if you're interested, I can send you a copy of the proof. But it uses the three sides A, B, and C. And first of all, there's something called S, which is half the perimeter, called the semi-perimeter. If you add A and B and C together, you get the perimeter. Take half that, you get this semi-perimeter. And the area is S times S minus A times S minus B times S minus C. Really interesting. So if you just have the three sides, you can even find the area. You know, when you need an angle. Here you need an angle, here you need the base and the height. So you can find areas of any triangles. We never did an example of the law of cosines, so I figured we'd do at least one of those. Let's assume angle A is 42.3 degrees. Angle B, we don't know. Angle C, we don't know. Little a, we don't know. Little b is at 12.9. And little c is 15.4. And one of the things to recognize, I guess, is when do you use the law of sines and when do you use the law of cosines? Well, one sort of brute force method, try the law of sines, and if it doesn't work, use the law of cosines. But some of these, for the law of cosines, the side and the side angle side are the two situations that you can use that for. For the law of sines, it's angle side angle. You've got two angles. The angle side, and the angle side, the ambiguous case. But to solve any triangle, if you look at this and say, okay, I've got angle A, I've got side B and side C. That's the side angle side. And you're going to use this A to that on the left side. A squared equals B squared plus C squared minus 2bc cosine A. These are the things you know. And if you've got those, you can find the side opposite. Or if you have the side opposite and you've got these other sides, you can use to find the angle A. So in this case, we don't know A. B, little b is 12.9 squared. Little c is 15.4 squared minus 2 times 12.9 times 15.4 times the cosine of 42.3 degrees. Now you can put all that in your calculator. Let me have at least showing here. So 12.9 squared plus 15.4 squared minus 2 times, here's where you might need the times, 12.9 times the 15.4 times, you don't need it here, I guess, the cosine of 42.3 degrees. Make sure you're in degree mode. And then when you press enter, that's what a squared is. you need to take the square root of your answer to find out what A is. 10.5 to 1 decimal place. Now you might say, how do we find these other angles? Well, at this point, it's usually easier to use the law of sines, because now you got everything. You can put the 10.5 over the sine of 42.3. That gives you the ratio. You know the B is the 12.9 over the sine of, you can use these 4 to figure out the angle B, or the 15.4 of the sine of C. You can use this and these that are given on the left to find the others, the other angle C. For this one, the sine of B, cross multiply 12.9 sine of 42.3 over 10.5. For this one, the sine of C equals cross multiply 15.4 times the sine of 42.3 degrees over 10.5. Almost the same, except for that 15.4 and 12.9. So 12.9 times the sine 42.3 divided by 10.5. That should give you angle, or the sine of B. You need to take the inverse sine of your answer to find the angle B, 55.8. To find C, you can use the same 15.4 times the sine of 42.3 divided by 10.5. That is the sine of C. You need the inverse sine of your answer. So you get 80.8. Now let's see if this worked. We have 42.3 plus 55.8 plus 80.8, and you get 178.9. Because of the rounding, this may not be exactly right. That's a whole degree off. That's a lot of rounding. So be a little careful. Rounding errors can, and you may need to adjust that, or maybe you should use all the values in there. So let me show you, maybe. Yes, I can. I've got time left. In your calculator, you have a part that you can get to in the math, down at the bottom of the math in the math. They've got Numerical Solver. If that ... means there's extra stuff there. Equation 1, you can put in the a squared, alpha a squared. Equation 2, you can put in the b squared, alpha b squared plus c squared minus 2 alpha b alpha c, 2bc, cosine. Now you got to use something besides a because you've already used a. So I'm going to use the theta on here, which is above the 3. The cosine of alpha theta. But that's going to be my a, right? When you press enter, you get essentially the formula. A squared equals b squared plus c squared minus 2bc cosine theta. Put in the values you know for angle A. You know it's 42.3. For little c, it's 15.4. For little b, you don't know. I'm sorry, little b, you do know, 12.9. And for a, you don't know. But if you're sitting right there on that one, you know these others. Notice this solve down here. You press the graph key. And it gives you 10.4, 7, 3, 7, 6, 5, etc., etc. You can do this for any of these. You might have to change the letters to make it work the way you'd like. That's the solver on your calculator. Okay, that's section 7.3.